We have studied about the scientific notations in the last lecture. Now we will study how to do basic mathematical operations using these scientific notations. So let's start. So let's say multiplication and division. Okay. We know about the multiplication and division of indices, right? So the rule of multiplication says if we have a to the power x and we multiply this with a to the power y, then we can write this as a to the power of x plus y. Okay. So if we have 2 to the power 2 into 2 to the power 3, we can write this as 2 to the power 2 plus 3, that is 2 to the power 5. Let's match it. So 2 to the power 5 will be equal to 32. Okay. Now if we multiply it separately, 2 to the power 2 is 4 into 2 to the power 3 is 8. So 4 into 8 is 32. So this is the method for multiplication of indices. For the division of indices also, there is, if a to the power x is divided by a to the power y, then we can say a to the power x minus y. Okay. Like a similar example, let's say 2 to the power 4 divided by 2 to the power 2. So we can say 2 to the power 4 minus 2, that is 2 to the power 2, that is 4. Now if we match it by doing it separately, 2 to the power 4 is 16 divided by 2 square, that is 4. So we get 4. Okay. So this is the rule for division of indices. So this same method is used for the multiplication and division of scientific notations. Let's do an example. Okay. So the first example is 4 into 10 to the power 3 multiplied by 6 into 10 to the power 8. Okay. Now what we will do, we will take the numbers together and then we will take these exponential terms. Okay. So 4 into 6 is 24 into 10 to the power 3 plus 8. Okay. So 10 to the power 11. We can further simplify it by saying 2.4 into 10 to the power 12. Okay. Now there is another example, say 1.25 into 10 to the power 10 into 3.27 into 10 to the power 5. Okay. So we take 1.25 into 3.27 into 10 to the power 10 into 10 to the power 5. So we will have this part into, so 10 plus 5, right? So 10 to the power 10 plus 5, or we can say this comes as 4.0875 into 10 to the power 15. Okay. Now let's see some division. Let's say 8 into 10 to the power 5 divided by 2 into 10 to the power 3. So we will take 8 by 2 into 10 to the power 5 by 10 to the power 3. Okay. So we will do 8 divided by 2 is 4 into 10 raised to 5 minus 3, right? So we can write this as 4 into 10 to the power 2. Now let's see another example. 7.25 into 10 to the power 8 divided by 5.22 into 10 to the power 7. So we will write as 7.25 divided by 5.22 into 10 to the power 8 divided by 10 to the power 7. So the answer will come as 1.38 into 10 to the power 8 minus 7, that is 1, or we can write 1.38 into 10, okay, that is 13.8. So this is the multiplication and division using scientific notations. Now we will also do addition and subtraction. Okay. So let's say we have these expressions. A into 10 to the power p plus b into 10 to the power p. So for this method 10 should have the same powers, okay. So we will write this as, we will take 10 to the power p as common, okay. 10 to the power p is common, and within the bracket we will add a and b, okay. So this term can be written as a plus b into 10 to the power p, okay. So let's say we have 5 into 10 to the power 3 plus 3 into 10 to the power 3. So we will write this as 5 plus 3 into 10 to the power 3, okay. So this is 8 into 10 to the power 3. Now if we have different powers of 10, then what we will do? Let's say we have 5 into 10 to the power 3 plus 1.2 into 10 to the power 4. Then we have to equalize these powers first, otherwise we will not be able to take this term as common, okay. So 1.2 into 10 to the power 4. 1.2 can be written as 12 into 10 to the power minus 1, right. So we can write this term as 12 into 10 to the power minus 1 into 10 to the power 4, okay. So we have already learned multiplication. So this is 12 into 10 to the power 4 plus minus 1, that is 4 minus 1, that is 3. So we have 5 into 10 to the power 3 plus 12 into 10 to the power 3. So we can write this as 5 plus 12 into 10 to the power 3, which is 17 into 10 to the power 3. Now 17 can be written as 1.7 into 10. So we can write this term as 1.7 into 10 to the power 4. Okay. Since 10 into 10 to the power 3, so 3 plus 1, that is 10 to the power 4. So this is the addition. Let's do another example. 6.65 into 10 to the power 4 plus 8.34 into 10 to the power 3. So if we take 10 to the power 4 as common, then this can be converted as 0.834 into 10 to the power 4, right? So we can write this as 6.65 plus 0.834 into 10 to the power 4. So this is equal to 7.484 into 10 to the power 4. Okay. Now we will see subtraction. Subtraction is also done in the very similar way. So if we have a into 10 to the power x minus b into 10 to the power x, then we can write as a minus b into 10 to the power x. So let's say we have 9 into 10 to the power 9 minus 4 into 10 to the power 9. So we will write 9 minus 4 into 10 to the power 9, which is 5 into 10 to the power 9. Okay. Now let's see another example. So let's say we have 8.54 into 10 to the power 8 minus 2.76 into 10 to the power 6. So we can write 8.54 into 10 to the power 8 minus 0.0276 into 10 to the power 8. So we can now take 10 to the power 8 as common, and we can write 8.54 minus 0.0276 into 10 to the power 8. So we get the result as 8.5124 into 10 to the power 8. Okay. So we have studied about multiplication, division, addition and subtraction of scientific notations. Now there is another problem. The problem is, for example, let's say we have this number 5.233457777 and so on. Okay. Now we cannot write this number with these continued digits. Okay. So we need to stop somewhere. So let's say we are stopping here. So what we will write this number as? 5.23345 or 5.23346, because since it is 777 after this, so the actual number will be much greater than this one, right? But it will be less than this also. So there is a method called rounding off the numbers. So there are certain rules which has to be followed while rounding off a number. Rounding off basically gives us the closest value to the true value, but while rounding off, we are actually talking about an approximate value, okay? And we try to make it as close as to the true value. So we will discuss about the rules of rounding off. Okay. So the first rule is if the digit to be removed is less than 5, then the preceding digit remains same. Okay. So let's say we have 1.25321. Okay. We want to stop it here, okay, up to 3 decimal places. So if we try to stop this number at 3 decimal places, then we are removing this number. This is 2. 2 is less than 5. So we can round off this number to 1.253. Okay. Let's say we have 9.34. We want to round off up to 1 decimal place. So we will have to remove 4. So we can write 9.3. Okay. Now let's say we have 162. We want to round off it to 2 significant digits. Okay, we will study about significant digits later on. So if we want to remove 2, then 2 is less than 5. So we can write this as 160. Okay. Now the second rule says if the digit to be removed is greater than 5, then the preceding digit increases by 1. Okay. Let's say we have 2.5267. We want to round it off up to 2 decimal places and we have to remove 6. So 6 is greater than 5. So we will write 2.53. That 2 is increased by 1. Suppose we have 8.72. We want this up to only integer place. We have to remove 7. 7 is greater than 5. So we will increase 8 by 1. So we can write 8.72 as 9. Okay. So the last rule is if the digit to be removed is 5. Then we have two different rules to it. If preceding digit is even, it remains unchanged. Let's say if we have 2.453, we want to keep up to one decimal place. We have to remove 5. Now the preceding digit is 4, which is even. So we write this as 2.4. If preceding digit is odd, it increases by 1. So let's say if we have 6.753, we want to keep up to one decimal place. We have to remove 5. The preceding digit is 7, which is odd, so we will write this as 6.8. Okay. So this was the rules for rounding off. In the next lecture, we will study about significant figures. Okay. So thank you.